Bernoulli trials, type 1, basic. So for our Bernoulli trials, our formula that we need to use is going to be the probability of OR successes is equal to n choose OR p to the power of OR q to the power of n minus OR. So we're going to be using this for all of our questions. So we have two examples here under just kind of practicing just using this equation. And we're going to look at the first example. I'm going to just call that example 1, and the second example we'll call example 2. So in the first question here, we have an unbiased die is thrown 5 times. So therefore our number of trials, n, will be 5. We're told then in part 1 that we want to find the probability of getting 1/6. So if we're looking at our success, number of successes I should say, is going to be 1. And that's basically getting a 6 is considered our success. And then P is basically our probability of success. So the probability of getting a 6 is 1 in 6. And Q is always the probability of failure. Well, what's failure in this case? Well, if success is getting a 6, then failure means not getting a 6. So therefore there are 5 other numbers that are not a 6. So in other words, getting a 1, 2, 3, 4 or a 5. Okay, so if we want to say probability of success, so that's getting a 6 and not getting a 6. So basically whatever your success is, the failure is always the not of that happening. Okay, so the first one then is we're trying to find the probability of getting 1/6. So it's n, which is 5, choose OR, which is 1, times p, which is 1/6, to the power of OR, which is 1, times q, which is 5/6, to the power of n minus OR. Well, n is 5 and OR is 1. So we just need to use our calculator. Remember, your NC/OR button on your calculator is what we're doing here for 5 choose 1. And if we put that into our calculators, we're going to end up with 0.401. And again, in the leaving cert, sometimes they'll be saying correct to 2 decimal places or correct to 4 significant figures, or in the 4 decimal places here either in this case. So just be careful, do I need to round my answer or not? So the second part of the question then says, find the probability of getting 3 6s. So again, we list our n, our p, our OR and our q. N is the number of trials, so that's still going to be 5. OR is the number of successes, so this time the successes must be 3. So in other words, we're getting a 6 3 times in the 5 throws. So we don't know where those 3 6s are occurring in the 5 throws. It's just that the fact that we're going to have 3 of these 6s. So again, P is our probability of success, and therefore probability of getting a 6 is 1, and the probability of failure is not getting a 6. So again, 5/6. So of course, if we want to get the probability of getting 3 6s in the 5 throws, then it's n choose OR, so that's 5 choose 3, p, which is 1/6, to the power of OR, which is 3, times 5/6, the probability of failure, to the power of n minus OR, so that's 5 minus 3. So again, if we put that into our calculator, we end up with 0.0322. Okay. And remember, your outcomes for these probabilities are always going to be somewhere between 0 and 1. If you're getting something that's greater than 1, you know you've done something wrong, because probability only lies between 0 and 1. 1 being a certainty and 0 being an impossibility, and everything else in between. Okay, so the third one then, if I go back up to the question, is we have to be careful here because it says getting at least 1/6. So at least 1/6 means that we could have 1 6, 2 6s, 3 6s, 4 6s, or 5 sixes because we only have 5 throws, okay? So we basically have to work out all of those options and add them, which would take quite a long time. Or we have to remember that in probability, when we're doing at least one, well, we have a rule for that. So I'm just going to go, see, can I squeeze it in here? Oh, sorry. So at least one 6 is 1 minus none. Okay. Now, if it was at least 2, it would be the probability, it would be 1 minus the probability of none minus the probability of 1. Okay. So at least 1 is 1 minus the probability of none. At least 2 is the probability of 1 minus the probability of none minus the probability of 1. Okay, so how are we going to get the probability of none? Well, again, we can work out to the side here on the left. N is our 5 trials, or the number of successes would be none. We're not going to get any 6s. P, the probability of success, we already know is 1/6, and Q, our probability of failure, again, we already know is 5/6. So they don't change in this. So we have 1 minus, so 5, choose 0, 1/6 to the power of 0, 5/6 to the power of 5 minus 0, which is 5. And again, if we sub all of that into our calculator, then we end up with 0.5981. Now, if there's an issue with calculators and you're not getting the answer, even though everything you've written down on the page is correct and it's matching what I'm doing in these examples, please just send me a message and I'll show you how to do it on your calculator if needs be, okay? And we can see what's going wrong. But remember to use brackets, okay? All right, so we're going to go back up to the question here, and we have the second example looking at the bad apples. So I'm going to move on to the next page, and I'll put the wording of the question on the next page again. So in this question here, we're given our probability in terms of percentages. So you have to remember that probability can be written as a decimal, a fraction, or a percentage. So you just need to, convert it into a decimal if it's given to you in percentage form. So we're given that 10% of apples are bad, and we have to find the probability that in a box containing 6 apples, there is no bad apple, just one bad apple, and at least one bad apple. So what we have to do is write down then what are our number of trials, what's our probability of success, and what's our probability of failure. So here we have 6 apples in a box. So basically, if we're going to pick an apple out of the box, there are 6 of them. So therefore we say our number of trials would be 6. Or is the number of successes. So in part 1, the number of successes is no bad apple, okay? Where our success is considered a bad apple, okay? Now, you might consider that being failure, but in this question it's a success. Now if you mix them up, it doesn't make a difference because your P and your Q will actually swap. You still actually end up with the same answer because everything will be applied then to what's considered success or what's considered a failure. So don't get hung up on that, okay? Whatever you're calling success at the start of the question is the same throughout the rest of the question. So if I'm looking at my success as being a bad apple, then the probability of success is the probability of getting a bad apple. Now we're told that a box of apples, 10% of them are bad. So that means that the probability of getting a bad apple is 0.1. So in other words, the 10%. So Q is our probability of failure. So what's failure? Well, a failure is actually getting not a bad apple, in other words, a good apple, and therefore if the probability of success of getting a bad apple is 0.1, probability of failure, in other words, not getting a bad apple, is 90%. In other words, 90% of the apples in the box are good, so therefore 90% would be 0.9. So for the first part of the question, we're looking to basically find no bad apple. So we're looking for the probability that we get no bad apple. Okay, and therefore we are going to have 6, choose 0, so n choose or, p to the power of or, so we have 0.1 to the power of 0, And then we have q, which is 0.9 to the power of n minus or. So we have 6, choose 0, which is 6. Okay, so that's our n, that's our or, that's our p, that's our or, that's our q, and that's our n minus or. Okay, so if I put that into my calculator, then the probability of getting no bad apple is 0.53144. Okay, so part 2, we then have to basically find that we get just one bad apple. So the probability of getting one bad apple. Well, 6 is our number of trials. Number of successes this time is going to be 1. Probability of success is still the same. Probability of failure still the same. And n minus or in this case is going to be 6 minus 1, which is 5. So therefore, I'll just go ... or is equal to 1 in this case, okay? We then put that into our calculator. We end up with 0.354294. And again, I'm putting down all the digits. I'm not rounding unless I'm told to in the question. Okay, so the last one then is at least one bad apple. So again, keyword coming up there is at least one, same as in the first example where we had at least 1 6. So again, at least one bad apple means we could get 1 bad apple, 2 bad apples, 3 bad apples. So therefore, again, for our probability of at least one bad apple is equal to 1 minus the probability of none. Now, of course, we've already worked that out in the first part of the question. So it's just 1 minus 0.531441, and that gives us 0.468559. So again, if you wanted to write that in terms of percentages, because we were talking about percentages at the start of the question, probability of getting no bad apple would be 53%, probability of getting one bad apple would be 35%, and probability of getting at least one bad apple would be 46.86%. Okay.